Alright, we're right back in here, another episode. And today at Water Power Planet, we're gonna talk a little bit more about the elements today. Well, I had a few electrical circuits overheat. I broke a few light bulbs. Now, unless you want to be mad as a hatter, you want to be careful with some of this stuff that you're working with, these fluorescent bulbs. So go back and read this. And this is a gas that's inside those bulbs. I just had one explode. I had another one break right next to me, right in my face. So you want to be careful inhaling things here in the laboratory. You want to wear your safety glasses. So we're going to jump right back in here in this episode. It's easy to break these globes. See, I just broke this one in a science experiment. Gases came out of it. This blew a capacitor. I had to get the old soldering iron out and repair this circuit. So we're going to talk more about the plasma circuit today. I guess we'll jump right into it. I'm going to show you something that's very important over here. Now, using this high voltage, I can energize just about any object you can imagine over any distance. That's what I've done here with this little wire. I got it hanging off the side here. It's going to send a spark gap through there. I'm going to be able to make just about anything I wanted. It doesn't matter how big it is, how big the antenna, how big the obelisk. Let me show you. Once I get that spark gap going, I can send an electrical discharge through any object, no matter how solid it is. And when the current's high enough, a lot of the things that you think are a resistor that won't pass electricity, like plastic and stuff, if the electricity is high enough, it will pass through it. Any material on Earth. Let me show you how this works. See how I've energized these huge weights? I'll have to set the pulse a little faster. But you get the idea. I don't even have to come in contact with it. But I can energize this large object. Let me push it over a little bit. There we go. Get it to pulse again. But you get the idea. See the capacitor smoking? It's going to blow. It's going to blow. That's how you make ozone. Might as well catch this on film. Smoking, it's going to go. It's just going to blow. Some of the stuff you got to look out for. Some of the problems I run into working with these circuits, they get overheated. God, that thing stinks. Might as well use it while it's running, but this is how you produce the ozone. It's very simple. Just getting a screwdriver near it, you can see the blue. We'll talk a little bit more about these Nobel gases. Some of them are really hard to get. Some of them you can make yourself through these Hoffman apparatus. Hydrogen, oxygen, nitrogen, chlorine, radon. But remember, that has a half-life of 3 minutes. That's not a gas that you'll be around too much. It comes from uranium rocks. But these are the Nobel gases. I wanted to cover the circuit today. That's what this was about. So I fried a couple of capacitors and I had to get the wand out. I had to do a little soldering. So I broke a mercury vapor bulb today. Just some of the stuff I was working with. Here's the back of the circuit. You can see it's very easy to take parts off of there, put them back on. Nothing to it. Transformer usually never fries. No, Tesla left us with this plasma globe. No, it's a highly advanced piece of technological equipment. I've been studying it for a long time. It has the ability to produce an atmosphere. It makes a molecular gas that you can get nowhere else on the planet. It does a whole host of things. It's been really tough to make these videos. I have to stay away from it because it wants to disrupt all my electronics, all my sensitive electronics. See, back in Edison's day, he didn't want Tesla rocking his comfortable boat, with his direct current. No, he electrocuted an elephant on stage in front of these sheeple. He wanted them to see it so they'd be in fear. He was making a lot of money on his patents and the light bulb, which he didn't even invent, and he got rich for. So it's just some of the stuff I wanted to show you guys. The plasma circuit. We're going to work with some HHO gas. We'll continue on. There's just some of the things I wanted to cover. And these plasma globes, there's still a lot to be discovered there, a lot to work with. It's an engineering marvel. Go back and read that. So these are the Nobel gases. And these plasma globes. No, they told these sheeple that they were nothing to worry about. No, they told them it was a novelty. Nothing to see, right? No, that's not true. No, that produces a molecular gas that shields life on planets. Yeah, think about that. Well, it's a transmitter, a radio transmitter for speaking across cosmic distances. It's so much more. It's a powerful machine. Those energies released that are more powerful than the sun. There's almost no resistance here because the voltage is so high. This has a lot to do with the water. Think about that. There's a connection here. The ozone's also a toxic gas. It's not something you want on the ground, on the surface. No, it belongs up in the atmosphere. It's a strong oxidizer. It's very much like chlorine. And all these gases are very different. They all have different colors. Hydrogen makes a different color. So it gives off this nice blue. Argon's going to give you a green. Neon's red. See, look at these old Soviet balls. Watch them light up. Especially when you're grounded and you're touching the ground and you touch them. No, there's a lot here. There's a lot more technology than they're telling you. And see, these plasma globes, they generate a lot of RF frequency. They have a huge inductance leakage. They generate noise. All electronic devices and circuits generate small random electrical currents. These things throw off a ton of it. When these currents are unwanted, they're called noise. Noise can obscure equally small signals very easily. It disrupts communications. Think about this. Certain communications, you got to be careful. Especially amplitude modulation, AM radio. Some radar, cell phones, military services can be completely disrupted with things like this. You have to be careful. Here's an AM radio.
Universo 1420 te da la...
See, and they can't communicate, they can't talk, because it completely obscures their signal, especially Tesla coils. Something to look out for. Completely block communications. I know what you guys are thinking. There's not enough energy there. No, we got to step up the power. No, that's a good idea. That's an excellent idea. You can always use more power, more energy. And what's going to happen when we step this thing up into the microwave range of radiation? Now think about that. So already you know you got to be careful around the radio waves. But what happens if you step up the power a little bit? Let's say we go to the microwave range of radiation. Let's try one of them rings. I think it's got nitrogen in it. Let's see what happens. Nitrogen argon mixture. Oh wow. Oh no, I think it blew. That was cool. So that's it for today's plasma globe of life and death. So that covers the plasma circuit today. Remember that thing's running at 5 kilovolts at about 35 kilohertz radio frequency.